let's graph some polynomial functions. And we're going to do several examples. And it would be very beneficial to write these examples down and copy them just so you'll have an understanding of how the graph looks. And there's so many little nuances. So we're going to do 6 examples and then just start talking about all the patterns that we notice in that, and we'll go from there. So let's start with this example right here. We're going to graph this function, f of x equals x squared plus x minus 2. I'm going to look and see what I had on my notes here. And we're going to just go ahead and graph it. Now, if you wanted to, you could grab a graphing calculator. You can type it on one of the online graphing tools that you have. You can do all kinds of stuff. I'm going to just jump straight to the fact that I know what this graph looks like, and then we'll talk about how I know what this graph looks like. And then we'll get to the point where you can go from here to here. So I'm just going to start putting some things up here. So on the x-axis at 1, on the x-axis at -2, and on the y-axis at -2. We're going to have 3 different dots, so let's put those down. Now, how do I know this? I'm about to show you. Okay, so don't panic if you're like, where are you getting all these numbers from, and how do you know? You'll see, you'll see. Okay, but again, if you wanted to, you could graph this in a graphing calculator or online. Okay, and because it's squared, I know it's a parabola, so it makes this U-shaped thing. So let's draw it as best we can. Better go through those points. Whoops, almost missed that one. There we go. And now we're going to talk about how we knew all that stuff. So let's just use some tools from our toolkit. Let's come over here and let's start factoring this. You know how to factor. So x times x gives me x squared. 2 numbers multiply to give me -2. We've been through this process. That would be 2 times 1, but the signs had better be different. So -2 and +1. Oops, that was wrong. +2 and -1. I'm sorry. Okay, so here we go. We just factored this into that, and these are going to factor. Everything we're going to do in the class today, in this lesson, is going to factor. And so I look at that and I say, well, how in the world did I turn this into this? Well, let me show you. If this was equal to 0, then we would be finding, and follow me closely, if this function equaled 0, we would be finding x-intercepts. Very quickly, here is why. The y value, f of x, the y value equals this stuff. And if y equals 0, then I'm telling you the coordinates that lie right here. Okay, so this coordinate right here is -2, 0, and this coordinate is 1, 0. So when I plug in 0 here, which I put it over here, then I have just found x-intercepts. So let's just continue this process. X plus 2 equals 0, so x equals -2. Okay. X minus 1 equals 0, so x equals +1. Okay, we just found x-intercepts. We can actually also find the y-intercept, and the y-intercept is going to be the easiest one to find, and it would be what I get if I plug in 0 for x. So basically it's this. I knew to put that dot right there at y equals -2 because of this -2 right here. And if you need to see it worked out, here we go. So for my y-intercept, then basically I said, well, if I'm going to find out what dot goes there, then it's going to be 0, something. In this case, it's -2. And what I would do is I would plug in a 0 here and see what's left. So I'd have 0 squared plus 0 minus 2, and that's equal to -2. There we go, we found it. So this is the y-intercept. Y equaled all that stuff, okay? So here's what just happened. I gave you an equation, I gave you a graph, and then we tied the two together by factoring, and factoring shows us our x-intercepts, and also plugging in 0 for x gives us our y-intercept. And that was a lot of stuff, but we also have some vocabulary we need to talk about. And we're going to just list a few things and talk about, well, all kinds of crazy stuff. So let's do some other stuff. Let's talk about the fact that this thing has a degree of 2. And I'm going to start making a list. It's going to be in tiny little letters over here, but I'm going to start making a list. So when my degree was 2, and my leading coefficient, which is 1, is positive, leading coefficient. Now, you don't have to write this part down. Don't worry about this over here. So if you're writing this, I apologize. You don't have to write this yet. So this is going to lead us to finding some other patterns. So we've tied a few things together between an equation and a graph, and now we're going to take this to lead somewhere else. So leading coefficient was positive. When I had that, I had this graph that went like this. Okay, so I'm just going to go up, like that. Okay, so there we go. There was our first problem, and I wrote it really small in the corner. But after we do all of the examples, then we're going to look back at this and say, oh, what was the pattern? What can we notice? Okay, so degree, leading coefficient was positive. Let's jump back over here, and let's start thinking about some other aspects of this. Okay, so I have this graph, and it goes down, and then it comes back up, which means we have a minimum. So we have one minimum value. I'll write it in blue because I feel like it. So we have one minimum. Okay, now we get into some tricky words. This is going to be called a relative minimum or an absolute minimum. Either word works in this situation. It is the absolute minimum because it is the lowest point on the graph. If it's one of the low points on the graph, like if it's in the bottom of a valley, then it's a relative minimum. So I'm going to say that I have one minimum. But if you see the word relative minimum, don't panic. It really just means minimum. But it may not be the minimum, like the minimum of all minimums, okay? So I have one minimum value. I have no maximum value because it goes up forever. And we also need to talk about the fact that we have two places that we cross the x-axis. We have one here, we have one here. So right here, I'm listing some things that I notice about my graph. We have one minimum, we have two x-intercepts. I'm going to call them x-intercepts, and then I'm going to give you another definition for them. So we have two x-intercepts. If I can spell it right. We have two x-intercepts, but because of the process we used to find those x-intercepts, where we set this equal to 0, they're also called zeros. Okay, so we have two zeros. And one more thing I want us to talk about, and this is where things get a little bit crazy. It has to do with the fact that this graph goes up on the left and up on the right. Now, that was this stuff that we'll eventually get to. So I'm going to go down here, and we're going to write some crazy stuff. So let's just say that as x approaches negative infinity, comma, okay, whoa, what's going on here? Here's what's happening. As I'm moving to the left on my graph goes up, right? Okay, so as x approaches negative infinity, it keeps going and going and going and going and going. So as x approaches negative infinity, the y value is going up. So I'm going to say as x approaches negative infinity, y goes up towards infinity. Let's go to the right now. As x approaches positive infinity, y continues to go up. So as I go to the right, the graph goes up. Okay, that was the first one. This is what we call end behavior. There was a whole lot in that. One problem where I introduced you to all kinds of vocabulary like zeros and end behavior. You've seen degree and leading coefficient, and we took some stuff we've done and we put it all together, and that was a lot. And that took way too long for one problem. And we have 5 more to go. Don't panic. I'm going to go faster through the rest of them, and we're going to continue to make our little chart. All right? So I'm going to erase this in just a second, but let's keep in mind that in this, we're going to be doing this process with all of them, but it's going to start going a little bit faster. So here we go. Well, I want to find out my minimums, my zeros. I want to get my end behavior. I want to graph it. So here goes. Let's do this. I'm going to leave that up. And then we'll start putting some patterns up here too. There's my marker. Okay. Negative x squared plus 2x plus 8. Okay, let's start factoring. Now, by the way, this one's going to be a little bit crazy. Also, by the way, I just skipped the problem. So I said we're going to do 6 total. I just skipped one. We're down to 5. All right, so I want to know where to put stuff here. So actually, I could go ahead and find out what my Y-intercept is. My Y-intercept is somewhere here on the Y-axis, the X-axis. It's somewhere here on the Y-axis, and it occurs where X equals 0, so I could plug in 0 here and here, and I'd get an 8 out of this deal. So I know my Y-intercept is at 1, 2, 3, 4, 5, 6, 7, 8. So let's just go ahead and put a dot right there. That dot, in case you ever wanted to know where it is, that dot is at 0, 8. 0, 8. And I'm skipping a few lines here. We're going to come down here and we're going to talk about the Y-intercept. And that Y-intercept occurs where Y equals 0 squared, actually negative 0 squared, plus 2 times 0, plus 8, which is 8. So I skipped a little bit, but I already know one of the dots on my graph. Let's get some of the other dots. Too many markers going on here. You can't have too many markers. All right, let's find out what the zeros are. Zeros is what I get not when I plug in 0, but when I set the function equal to 0. So let's do that. Let's do some crazy stuff here. First of all, we have never factored one that had a negative in the front, and I don't want to start now. So we're going to divide everything by -1. I'm not going to show that step, but let's just cancel all the negatives out. There we go. And now we'll factor. This is equal to 0, so x minus 4, x plus 2. I'm going kind of fast. And so we kind of know a shortcut. That's a dot on the board, by the way, if you're like, what's that decimal for? So x minus 4 equals 0, so x equals positive 4, and also x equals negative 2. So now we know how to graph this thing. So we're going to go over here to positive 4, 1, 2, 3, 4, and negative 2. And we have this graph, and it looks like this. Okay, so it comes up. It probably goes up higher than that, but this is a rough sketch. All right, I'm going to grab my skinny little marker. I'm going to walk over here, and we're going to just list a few things that will eventually help us notice some patterns. My degree was 2. You don't have to write this down, but this is going to help us notice patterns. My leading coefficient was negative. Again, this is going to come in handy near the end of the lesson when we're finding patterns. And the graph went down, down. And so that's going to help us start figuring things out. Let's go ahead and discuss end behavior while I'm standing here at the board with a green marker conveniently in my hand. So for end behavior, we need to see what happens as we go to the left and as we go to the right. So let's just write that. So as x approaches negative infinity, that's just my way of saying we're going to move to the left. Tell me what the graph does. So let's move to the left. Tell me what the graph does. Oh, it goes down. Okay, so I'm going to the left. My graph's going down. So as x approaches negative infinity, y approaches negative infinity. It's going down. And then as x goes to the right, as x goes this way, what happens to my graph? It goes down. So as x approaches infinity, y approaches negative infinity. Okay, well, that was easy. All right, a couple more things to do. Let's list a few other aspects of this graph. And we have 2 zeros. You can call them X intercepts if you like. And we have a maximum or a minimum. We have something, and it's right up here. Well, if it's right up here, then it must be a maximum. So this graph has a maximum, one maximum, and again, you could say it's a relative maximum, you could say it's an absolute. Those are words that we're not going to argue over right now. So if you see the word relative maximum or you see absolute, not an issue at this point, but you know that it is a maximum. So I have one maximum. Okay, that is the end of the second problem. We were going to do 6. I have just trimmed it down a little bit. Let's move even faster, and let's do a few more. Okay, Up to this point, we have done one that had an even degree with a positive leading coefficient and an even degree with a negative leading coefficient. I'm going to do one that has an odd degree and a positive leading coefficient. That was wordy, but you'll see what I mean. So we have x cubed minus 2x squared minus 3x. That looks like it just floated way up there as an exponent. That's unacceptable. So minus 2x squared minus 3x. There we go. Let's draw a graph. This one's going to get crazy, y'all. This one's going to get really wacky. I'm going to skip a few lines and just jump right down here to the Y-intercept and find out where I am on the y-axis. That was a whole lot of vague pointing just for me to say that I'm about to find out where I put my dot here. In a minute, I'll find out where I put my dots here. Okay? Let's find the y-intercept. The y-intercept is best found by plugging in 0 for x. So this is a y, so y equals, this can happen in your head, 0 cubed minus 2 times 0 squared minus 3 times 0. That would be 0 minus 0 minus 0, which is 0, which means my y-intercept is 0. So that was easy. I have a dot right there. Okay, so let's keep going. Let's keep gooving. Swedish. So we're going to set this equal to 0 and solve it. So x cubed minus 2x squared minus 3x equals 0. What are we going to do? Well, let's factor. How are we going to factor? We always look for a greatest common factor first, and I see it. It's x. Every term has an x, so we factor that out. There we go. What are we going to do now? We factor a trinomial. Told you I was going to go fast. We have 5 examples and a review to go over. I say review. We're going to kind of piece it all together at the end. X, random dot. 2 numbers multiply to give me -3. That would be -3, +1. So I have 3 x-intercepts. Let's go backwards and find them. X equals -1. X equals +3. Boom, boom, and here's one. And here's what we did. We just said, if I set this equal to 0, I'd get that. If I set x minus 3 equal to 0, I'd get 3. If I set x equal to 0, then I have x equals 0. I have 3 x-intercepts. They are at 0, 3, and -1. -1, 0, we already had that one, and 3. Okay. We go. Okay, so up until this point we've had parabolas, and parabolas went, or maybe they went, but now we're about to have like that. It's about to get a little bit different, and maybe, just maybe, it goes instead. All right, so there is a way to figure out which direction it's going, if it's or whoop. And the best way to do it, well, is to know the pattern. But for now, if you wanted to, you could graph it, and you could find out that it actually does this. I'm going to just jump straight into it and show you what it does. We can go up, and then down, and then up. Now again, you could say, well, how do I know that it goes like this and not down, up, down? There's a way to test points. Actually, here's a great way to do it. Very quickly, I'll show you. If I want to know what happens at x equals 1, I can plug in a 1. 1 cubed, 1, minus 2 times 1 squared. So 1 minus 2 minus 3 gives me a negative, which means my point is down here, not up here. So that's a good way of testing if it's positive or negative. Just plug in a random point. Don't panic if that didn't make sense. Okay, let's walk over here. You don't have to write this part down, but let's find a few little parts to the pattern. My degree, the original highest exponent, was 3. My leading coefficient was 1, understood +1, so I'm going to say that it's positive. And this graph is going down on one side and up on the other. Down to the left, up to the right. Let's put some arrows here. While I'm standing here, with the green marker conveniently in my hand, let's talk about end behavior. As x approaches negative infinity, we'll just always start by going to the left. It's just a good habit. As x approaches negative infinity, my graph goes up or down? Well, down. Well, if it's going down, it's going towards negative infinity. For now. Then y approaches negative infinity. As x approaches positive infinity, in other words, my graph is moving to the right, as x approaches positive infinity, my y value is going up. So y approaches positive infinity. Okay, a couple more things to do. Here we go. I have 1, 2, 3 zeros. 1, 2, 3 of them. It's great. It's fun. Aren't you excited? Me too. So I have 3 zeros. And I also have, let's ride a roller coaster. I have a maximum and a minimum, and then it goes up forever. So I have 1 maximum, I'll abbreviate it as max. I have 1 minimum. They are, let's get technical with vocabulary here, they are actually relative maximums and relative minimums because the graph does keep going up forever. Because the graph's going up, that is not the highest point. If this was a roller coaster, you'd reach a peak here, but then you would keep going up forever and you'd never, ever, ever stop going up in this roller coaster. It would not be a fun ride. You'd eventually end up in space. You have you have one that has a minimum. You have a minimum here, but it also goes down forever. So it is not the absolute minimum, it's a relative minimum. Don't panic about the vocabulary, but I want to show you that. Okay, 2 more. I'm speeding up even faster. Slow the video down if necessary, but this is a long lesson that has a lot of stuff in it, and there's no way to really chunk it together and make it concise. So let's go to this one. Negative x to the 5th plus 4x cubed. And I'm going to have a graph. This one and then one more. Actually, the one after this one is even shorter. It's much shorter, actually. And I'm going to go ahead and go to 2 because I know it does. These are going to go out to 2 and negative 2. I like to start with my green marker on my Y-intercept. My Y-intercept is where I cross the x-axis. My Y-intercept is where I cross the y-axis. I plug in 0 for x. That was wordy, but here it goes. Plug in 0 here and here. I'm going fast, y'all. Negative 0 to the 5th plus 4 times 0 to the 3rd. That is 0. That tells me that my y-intercept is at 0, which really tells me I also have an x-intercept at 0, but you know, we'll get there. All right, let's set this equal to 0 and solve. Negative x to the 5th plus 4x cubed equals 0. That was a waste of a line right there. I should have put that there and used this line to factor. You wrote that already? I'm sorry. Let's factor out a greatest common factor. It is going to be x to the 3rd. See, every term, both terms, have x to the 3rd at least. That one has x to the 5th. X to the 3rd. And when you are factoring out a greatest common factor, if your leading coefficient is negative, you should factor that out too. It'll make everything else much easier to factor. Trust me, you'll see where this is going in a minute. X squared, because like 3 plus 2 is 5. Okay. And then 4 divided by negative 1 is negative 4. That's equal to 0. Let's keep factoring. Negative x cubed, x plus 2, x minus 2 equals 0. And we're going to have x equals 2 from that one. X equals negative 2 from that one. And over here we got this, and I'm going to write it here and then erase it. But if I was to set negative x cubed equal to 0 and solve it, I would divide by negative 1. That's an ugly negative 1. But I'd have x cubed equals, well, 0 divided by negative 1 is 0. And then I would take the cube root. And the cube root of 0 is 0. So I still get x equals 0. Okay? But this is where things get very different. If you were to graph this one on a graphing calculator or graph it online, you would see a very bizarre thing that takes place. Let's put a couple dots and we'll go from there. Okay, there is a negative in the front. So what was normally, you haven't learned this yet, but what was normally whoop, now becomes woo. So my graph is going to come down, pass through there. It's going to come up, and then something crazy is about to happen. And here's what it is. Because at 0, I have what is called a triple root, it's going to do this thing where it doesn't just go whoop, straight through it. It's going to go whoop. If you graph this online, you'll see it. It's really cool. It goes zoop, like that, and then it needs to turn back around and pass through that point. Let's not get picky about how high and how low and all that stuff. Okay, so there's this funky little thing where it goes, and that's a triple root. Okay, let's write, drop my green marker. Let's write a little bit here. My degree was 3. Oh no, my degree was 5. My degree was 5. My leading coefficient was -1. And this graph was up, down. Up, down. In just a minute, we're going to take this stuff and make a little chart out of it. It'll be so easy. All right. Here goes. Oh, end behavior. Let's go back over here. As x approaches -infinity, let's always just start by going to the left. As I'm driving my car to the left, I see a graph overhead. It's going up. My graph's going up. So y approaches infinity. As x approaches +infinity, now we're going to drive it to the right. As I'm going to the right, my graph's going down. Long term, my graph goes up and then back down. But long term, my graph is going down. That's the end behavior. So it's going towards -infinity. 2 more things. I have 1, 2, 3 zeros. I could also call them roots, by the way. I've called them 2 things so far. I've called them X intercepts. They're also called zeros. Here's another word that it's a lot of vocabulary in this lesson. X intercepts, zeros, and roots. Okay? And you can call them any of those things. And I have 1 maximum. It's right here. Now, it is not the highest I ever go on this roller coaster, because the highest I go is forever up. And I have 1 minimum, and it's here. And it's not the lowest I go. The lowest I go is down here. It goes down forever. But I do have a minimum, and I have a maximum. I have peaks and I have valleys. Okay, we're going to do one more, but the big idea behind this one, well, a lot of things, but one of the bigger things that we can focus on is that right there. The fact that when I have a triple root, it doesn't go, it goes like that. Okay, one more. Aren't you glad I cut that other one? I cut number 2 and jumped straight to number 3. The second problem on the set of notes was going to be, well, a lot like the first one, so I figured I would just jump straight into this. So negative x squared plus 6x minus 9. I want to show you what this one looks like. And let's just go ahead and set this equal to 0 and solve, and let's do it fast. There's the greatest common factor of -1, because I just don't like having a negative out there. X squared minus 6x plus 9 equals 0, so negative, and then x minus 3, and x minus 3, which equals 0. And I'm going to do one more thing that might seem unnecessary, but because this is repeated, I'm going to say that it's really squared, okay? Which really means that x equals 3 is the only place that I touch the x-axis. Notice I didn't say only place I cross the x-axis, because I won't cross it there, I'll just touch it there. You'll see what I mean. 1, 2, 3. All right, let's go ahead and find the y-intercept, which should be pretty easy to do. My y-intercept is going to be what happens when I plug in 0 here and here, so my answer is -9, so y equals -0 squared plus 6 times 0 minus 9, and that is equal to -9. So down here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's start plotting some points. There's one. There's one. And that's it. Okay. Up until now, we have always had more than 1 0. Like when I make my list here, I'm going to be like, we have 1 0. That's it. 1 real 0. Sometimes they'll be called real zeros because there are non-real zeros, but I'm just looking for places I cross the x-axis, okay, or touch the x-axis. If you were to graph this one, you'll notice that it does this right here. So here's the big idea with this one. The big idea is if I have a double root, it bounces off. We will revisit this idea in another lesson, but if I have a double root, it bounces off the x-axis. All right, let's do end behavior. As x approaches negative infinity, y approaches, it's going down, negative infinity. As x approaches positive infinity, y is going down, so y approaches infinity. I'm not going to put anything over here because I actually already have it. I already have a degree of 2 with a negative leading coefficient. Down, down. Okay, a couple things. 1, 0. Again, some people will call it a root, some people will call it an X intercept. I'm calling it zeros, and I have 1 real 0. I touch once, bounce right off. And then I also have, what was the other thing I've been writing? Oh, I have 1 maximum. I have 1 max. No minimums, because I keep going down on both sides. Okay, whew, that was a lot. Let's put all this together. Let's take all the stuff that we did right here, and we're going to make a little chart out of it. And then I'm going to just doodle a little bit, show you a couple things, and then that'll be it for understanding the big picture of graphing polynomial functions. Okay. So sometimes, let's take a deep breath. Sometimes my degree is even, sometimes the degree is odd. Sometimes the leading coefficient is positive, sometimes the leading coefficient is negative. And all of that dictates my end behavior. I know I'm dancing awkwardly, but you'll see what I mean in a second. So let's make a chart, and it's going to be this. My degree is even, and my degree is odd. This is going to look like the box method, but it's not intended that way. And then my lead coefficient is positive, or my lead coefficient is negative. There we go. Okay, there's a lot going on in this lesson. There's a lot to take in, but let's just look over here on the stuff you didn't have to write, and let's put it in this chart that you do need to write. So if my degree is even, like 2, then I can have a positive, if I have a even degree and I have a positive leading coefficient, then it goes up, up. Up, up. So we could say that, now if we're going to get technical, I'm not going to write this, as x approaches negative infinity, y approaches infinity. As x approaches positive infinity, y approaches infinity. It's going up, up, okay? If my degree is even and the leading coefficient is negative, it goes down, down. If my degree is odd and my leading coefficient is positive, it's down, up. If my degree is odd and my leading coefficient is negative, it's up, down. That seems like a lot to memorize, but it really becomes pretty straightforward after a while. So very quickly, I'm going to just draw a graph, or 2, or 3, or 10. So if I give you this graph, and I say, hey, what's its degree? And you're like, I don't know. Yeah, you do. Well, I may not know the number, but I know this. See that down, down? There's a graph somewhere. That down, down, boom, boom. My degree is even, my leading coefficient is negative. Y'all see it? Okay, let's do another one. Zoom. There we go. This is up, down. Up, down. My degree is odd. My leading coefficient is negative. So, odd, negative. This one was even, negative. If I give you this one, zoom, zoom, then down, up is odd and positive. Cool, huh? Of course it's cool. You know you like it. And then we could also talk about how many zeros you have. We could talk about maximums, minimums. I could give you an equation. I could say, hey, suppose this is a function. You don't have to write this. If I have this function, next to the 7th, and I say, what's its end behavior? You wouldn't be lost. You got this. Okay, let's just look. The degree is 7, so the degree is 7, which is odd. The leading coefficient, LC, is 6, which is positive. Odd, positive, it's going to be down, up. And in some ways, in some methods where you do this, you'll have to say, as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity. So those are the big ideas on graphing polynomial functions. There are certain aspects of that might have gone very quickly. For example, the fact that graphs can do this, don't write that, or graphs can bounce off of an axis like this if it's a double root, or that if it's a triple root. Don't panic about those things. Those are other bigger ideas that will be fleshed out a little bit more later.